background of myself. I graduated from the University of the Philippines, Manila. Um, um, Last January 2020. That's 2013. 2020. Kunyari lang. Feeling lang. 2013 sa Manila. Then I took the board exam. Pero ginawa ko siya when I'm doing medical school already. So, so the starting med school is when people of 2030 that very board exam namin is at the end of June of 2030 that time. So, medyo mahirap yung part ko na yun nga, I'm pursuing another path and tinatapos ko yung path ko as a pharmacist at time, want to be registered. No? Parang may, meron ang tawag doon pag sa relationship. May parang, ano ba yun? O basta yun yun. Ang nabili ko daw, hindi daw all. Pwede mo babawasan ng ito yun.
Recording.
Yan. Hello? So, mas medyo maikong nga talaga siya. Mas ulitin ka ba? Mas malinaw naman. Sa mga PSC subscribers natin. And just first sa mga ganito set up. Mas malinaw na ba? Anyone? Yan. So, sa mga hindi na kayo, mas malinaw mo na so, ako yung si Dr. Nico, Koreana Venture. Ayan, ganun ko ba ng sir? What happened ba? Yan ba? Mas malinaw ba? Ang hirap naman, no? Teka lang. Kailangan malapit ako sa computer. Siguro. Siguro dito na lang yung data. Hello. 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 Ayan. Mas malinaw na ba? Hindi ko kasi na-implement. Pero pakita ko lang guys. Okay lang. May time lang. Mas maganda wala na rin ako. Wala kasi kami ko dito. Guys, I assure I trust you guys yung mga nalito sa St. Jude na lahat tayo ay ayan. Walang may dito sa pod nilalagnan. Wala naman. Sure ah. Hello. Ayan. Oo, sir. Before tayo magsimula, mas maganda yung malitaw na yung alayo ng nararamdaman natin kapag tayo nagkakaproblema sa audio. Guys, okay lang po lang. Okay na. Sir, ito, nakikita ko Echo daw. Feeling ko, hindi, naka-close to actually. Alam ko na. Kailangan ito ma-close. Dalawa yung mic. Subukan natin. Sa ibang influencer, meron kami dati may gamit lang na parang may kino-connect na parang something na parang yung tapos parang zoom hindi ko na sure. Na-amaze din ako kasi one time nag-event kami. Yung ganun. Parang malinaw yung kung ano yung may na microphone, narinig niya marunong sa online. Subukan mo makikita. Pero hindi ako masyadong take ng virus. Hello? 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 Kaso maririnig din ito, no? Yung ba yan? Kasi. Hindi na ako mag-microphone, dinig nyo naman ako, no? Hello? Ayan. Mas malinaw na ba, guys? Yes po, ayan. Okay. Okay. So, hindi na tayo magma-microphone. Okay. So, ulitin ko ulit yung introduction to. Sorry, nag-consume tayo ng time. Pero, buong araw naman tayo, guys. Yun, mahaba itong araw na to. So, please bear with me. So, by the way, I am Dr. Victoriana Advento Jr. So, I am a licensed pharmacist and also a medical doctor. I graduated from the University of the Philippines, Manila, noong June 2013. Feel ko talaga yung 2020, ano? So, 10 years ago. Okay, guys. So, there's an age gap na talaga, no? Sa ating, ano. So, 10 years ago, no, I graduated from pharma school. Then, after nun, I took Doctor of Medicine at the Pamantasan ng Luzon ng Maynila. No? So during that time, I nag-take din ako ng board exam ko noong June 2013. So that time, I'm already nasa med school na ako noon. So medyo mahirap kasi imagine mo naggagawa na ako ng assignment sa pharma, sa med school, and
med school is a different um, life na talaga. As in, everyday, iba-iba yung ginagawa mo talaga. And yun, luckily, umasa naman ako that time. So, na-close ko na yung chapter ng pharma that time, no? Pero hindi ko expect na after years, no, na bumabalik ako sa pharma to share what I know, no? Now equipped with personal experiences sa medications. Also, I'm an internist. I graduated from Jose Reyes Memorial Medical Center, no, last December 2021. Then I finished the deployment last year lang. So currently, I'm just waiting for the fellowship season. That's why I'm teaching. No. So yun nga, no. I chose the longer path na nag-medicine ako, no. And that time when I was a student, sobrang lost na lost din ako. I relate with you all, no? Medyo lost ako sa pharma kasi currently, medyo memorize lang tayo dito, no? And hindi tayo masyado nakakita ng patients, no? And how drugs work, pero pag makita nyo talaga in actual practice, in our actual setting, very amazing talaga yung nagagawa ng mga drugs natin and very brilliant yung mga discoveries ng drug, no? So, currently, no, dahil hindi pa tayo tapos, hindi pa pala ako tapos yung topa ko doon, no, hindi pa tapos. Kala nyo tapos na, no. Currently, I'm taking Masters in Hospital Administration sa UP Manila din, no. So, wala na akong katapusan. wala na. So, ano naman dapat talaga lifelong learning talaga yung ginagawa natin at saka yung goal natin. We will not stop learning. Dapat ganun din sa life. And after 10 years, ano na kayo noon that time, dapat. Hindi ko rin in-expect na ganito yung, na after 10 years, no, when I received my diploma, hindi ko naman din naisip na magtuturo ko sa mga pharma students like me before. No, ng pharmacology especially kasi ito yung isa sa pinaka-hardest na subjects natin, no? And relatively when I entered med school, ito yung parang edge ko sa iba. Because I have parang background, no, on the syempre iba yung pharma sa med school because it entails yung application then at saka yung correlation with the human diseases, no? Pero syempre yung sa atin is more on drug discovery, structure, and how it works, no? So, in relation to that, no, we'll start with the introduction to pharmacology. Then, meron na kayo ng handouts? Wala pa. Na-send na? Hindi na pinaprint out. Pero meron na kayo. Okay, so dun sa may mga access. So, in this 2-day lecture, so it is yung ito yung part 1 ng lecture na natin. So, I am tasked to divide yung coverage to 4 parts. So, ayun. So, yung first part will be 8 topics, no? So, yung una is yung introduction to pharmacology. Then, meron tayong cardiovascular drugs, no? Doon yung mga hypertension, ischemic heart diseases, no? And heart failure. Next, meron tayong arrhythmia, no? Anti-arrhythmic drugs. Meron din tayong anti-lipidic drugs. So, yun yung first day na target ko matapos. Kung hindi man natin matapos, kahit yung first 3 lectures lang. So, medyo exhaustive to, no? But I want to stress and to emphasize concepts na mas maintindihan ninyo. And hopefully, ma-execute ko na successful, no? Kasi medyo mahirap. Looking back, nung ako ay student din, hindi ko rin siya naiintindihan. No, I feel you guys. Pero, ang challenge sa inyo is to read more. Siyempre, ginawa ko ng inilaban, hindi pwedeng hindi mo naiintindihan. Kasi siyempre, this part, no, very thankful, dapat maging thankful kayo doon sa um, sa PINMA dahil nga ang gusto nila is for you to to understand more yung mga lectures, no, na mas maintindihan niyo siya kasi at this time dapat mas understood nyo na yung concept before nila kayo pakawalan. And when you go there outside, no, preparing for your board exam, no, kung saan man lupalop kayo pupunta or what. So doon yung memorization part, no. So this is part of your preparation sa board exam. So I believe most of the attendees are fourth year. Tama? Fourth year na kayo lahat. Okay, tapos bukas daw may mga third year. Ilan sila? 19. Okay, dito sa sa Sinju. Okay? So yung first part natin medyo mahaba, no? Pero yun nga, feel free to take down notes, no? Kung ano yung mga kasi relatively in-update ko rin tong slides ko with which is different dun sa different dun sa handouts. Pero sobrang minor lang naman yung mga revisions. Ayan. So dito start tayo sa mga definition of terms, no? Pharmacology is the study of the study of drugs. From the Greek word pharmakon means drug and logos to study. Hence, the study of substances that interact with living systems through chemical processes, especially by the binding to regulatory molecules and activating or inhibiting normal processes. Nilagay ko lang yan, no? That is definition based on Katsung. Pero basta pharmacology, syempre, that's the study of drugs. And there are different branches of pharmacology. So first is the branch is medical pharmacology, which is the science of substances to prevent, diagnose, treat diseases. So also known as pharma therapeutics. Toxicology, on the other hand, is a second branch, no, of pharmacology that deals with the undesirable effects of chemicals on living systems, from individual cells to humans to complex ecosystems. And this toxicology is further divided to it is subdivided, parang another sub branch, no, is environmental toxicology, since most drugs naman is coming from the environment, from plants and animals, no. It is concerned with the effects of chemicals on all organisms and their survival in groups as species. So the third one is pharmacodynamics, which we will discuss later, and fourth one is pharmacokinetics. So some terms, no? Ito yung materia medica. This is the science of drug preparation and the medical use of drugs. So it contains yung mga drug preparation. So this is a materia medica is from the Latin word history of pharmacy, for the body of collected knowledge about the therapeutic properties of any substance used for healing. So it is coined by Dioscorides, no? So from the practice of pharmacy economy. So the term materia medica was used until from the period of Roman Empire to the and now converted to the term pharmacology, materia non-medic. Pharmacogenomics, on the other hand, is the relation of individual makeup to his or her response to specific drugs, close to becoming a practical area of therapy. So this is a new venture, no, that drugs can be used through genomics, no, of a human. So individualized drug therapy. So by definition, drug is any substance that brings about a change in biologic function to its chemical function. It can be an acid or an acid or a weak base, and it interacts with as an agonist or antagonist. And it must have the different size, electrical charge, shape, and atomic composition. And also, it may be synthesized within the body or maybe chemicals that synthesize in the body. So also, yun yung mga tawag natin yung symbiotics. No? And usually, it is administered at a location distant from the intended site of action. Nawala. Ayan. So like poison, no? So we have poison. So poison, these are drugs that are almost exclusively harmful effects. So on the other hand, we have toxins. These are drugs, you know, defined as poisons of biologic origin. So it can be from plants or animals. And also, drug can be curative, no? Which aim to be a direct treatment for a specific disease. For example, PNG as a treatment for gonorrhea. So that is curative. And also, drug can be a symptomatic drug, no? The drug which is meant to relieve symptoms only. So not the drug, that the disease itself. For example, Decolgen. Ano bang component ng Decolgen? Dapat, paano nyo may bebenta? Wala na, hindi nyo na nabenta. No? Hindi nyo na nabenta. Pagka may sino ng mga butika dito, no? So, pag kunyari, pabili nga po ng Decolgen. No? So, yun, Decolgen to relieve cold. So, ano naman? Di ba may mga, hanapin nyo na lang. Mga assignment. Dapat alam nyo yung mga ganun. Kahit alam nyo yung mga components. Diba tatlo yan? Sige, Okay lang ba? Sige. Ano laman nga nun? Anong alaman? Okay, pwede kayo mag-participant TFC subscribers sa chat box. Okay. Wala yun. Okay. So, check nyo na lang. No? So, siyempre may antihistamine yan. O anong antihistamine? So, check nyo mamaya. So, it can be palliative. So, the aim is to increase the quality of life in patients with terminal illness. So, example dito ay yung mga analgesics natin. So, for example, patients with cancer. No? And usually, mga cancer patients, meron yung mga severe pain, no? So, siguro may mga relatives kayo na may cancer. Siguro, di ba, salamin nyo naman, guys, no? So, hindi lang yung kausap ko din yung, kausap din natin yung mga TFC subscribers natin. So, ayun nga. So, analgesics, we can be, they will not, ang intention ng analgesic is to relieve the pain, no? Relatively, kung may masakit kayo sa katawan, di ba wala kayong pakinabang, di ba, guys? So, ganun din, no? Relatively, yung pain nila, sobrang sakit tayo, umiiyak sila, no? And it is very excruciating na relatively, they need an opioid, like morphine, no? To, parang tawag dito, para ma-level yung pain. So that is palliative. Okay? So nakikita niyo yung differences, no? Curative, symptomatic, palliative. Next is supplemental. So this is used to support in order to fortify general well-being. So example is daily consumption of multivitamins, no? For example, di ka naman masyado kumakain or puro karne ka lang, no? Wala kang gulay, gano'n, no? So, relatively, ang aim ng multivitamins is to supplement other vitamins na hindi nyo nakukuha doon sa food, no? And hindi, kung sa tingin nyo naman na kumakain naman kayo ng maayos, no? Actually, hindi nyo naman kailangan ng multivitamins, no? If you eat variety of foods, gulay, kumakain ng karne, isda, no? So, doon mo makukuha kasi yun, no? Pero kunyari, ikaw, puro, may mga certain diets, kunyari, mga elderly, no? Siyempre, yung diet ng mga elderly, hindi na kasi parehas sa diet ng, kasi kagaya nyo na milk tea, mga ganyan, tapos picture sa post sa Instagram. Parang relate na relate yung mga students ko dito, no? No? So yun. So, relatively, yung mga, kaya nagsusupply tayo na ng multivitamins, kunyari yung mga gatas, no? Iba yung gatas ng pang baby sa matanda. Kasi syempre magkakaiba ng needs, no? So yun yun. Okay? So next is diagnostic. So the main use is to determine underlying illness. For example, edrophonium hydrochloride for the test to test the myasthenia gravis, no? So edrophonium is not used as a treatment but to diagnose kasi ang edrophonium is short term lang yung effect, no? So relatively pagka nag-improve yung muscle, familiar kayo sa myasthenia gravis? Yung myasthenia gravis yung relatively nagkakaroon ng muscle weakness, no, during the night, the afternoon. Mabilis ma-exhaust yung energy nila kaya nangyayari ng sila. So pag in-inject mo ng edrophonium, relatively yung muscle nag-improve, lumalakas ulit. So pag lumakas yung in the next lectures, if further discuss ko yung tensolon test. Hindi lang kasama dito sa lecture ko this part. Pero yun, no? So these are the differences, different drug categories based on use, no? So malinaw naman, okay? So there are some general concepts lang tayo, no? So first, no, drug is administered, no, and disintegrated, no. So at this part, so the drug is a pharmaceutical. So pharmaceutical is the substance used to diagnose, treatment, ganyan, no. So relatively, it is in pharmaceutical, it is in the drug form pa, no. No. So after this, it is disintegrated. It will be absorbed, distributed, no, metabolized, and excreted in the body. Next, after that processes, it will bind to drug receptor. There's a drug receptor interaction, and lastly, drug effect or response, no, depende kung desired or undesired. And to aid you with in memorizing these concepts, no. So liberation is the only pharmaceutical phase, no, ng drugs. Then once it is absorbed, distributed, metabolized, and excreted, it is in the pharmacokinetic part. Then pharmacodynamics occur during response, no, and toxicology. So dito na yan sa last part. Response and toxicology, dyan pumapasok yung pharmacodynamics and pharmacotherapeutics. So pakitandaan lang na the liberation is the only pharmaceutical process. Board exam question kasi. So pakitandaan lang, guys. Ayan pala, nandiyan pala, nasulat pala. So pharmaceutics or pharmaceutics is study of pharmacotechnical factors in drug products that can affect pharmacokinetics of the drug. And liberation is the only biopharmaceutics process. So paki-star. So let's before we start, let's before we tackle yung mga different concepts, let's go back, no, to the basic concept, yung the cell membrane. So kahit saan, hindi kayo makakatakas sa dyan. No? Medyo, ano lang to, medyo boring talaga yung, may yung mga students ay na-antok na. No? So, magkape-kape muna para, makatagal tayo. So the cell membrane is postulated by different physicians, no? Different theories were developed on how cell works. So first proposal is the lipid bilayer or the unit membrane theory by Dixon and Dionetti. No? They said that two layers of phospholipid between two surface layers of proteins exist. So there's a hydrophilic head, and that consisting of groups of phospholipids facing the protein layers, and the hydrophilic tail groups aligned to the interior. So ito yan, no? So nakikita nyo dyan that there's a protein layer, no? This one. The protein layers are nothing to be layers, no? Forming a lipid layer. And the second theory is the fluid mosaic model, which is coined by Singer and Nicholson. According to this model, globular proteins embedded in a dynamic fluid, lipid bilayer matrix, forming protein icebergs in an oily sea. Yan. So para lang daw siyang lumulutang yung mga proteins, no? Sa paligid ng mga oils or fat. And lastly, the modified fluid mosaic model, wherein proteins are embedded and are used as receptors for transport. So yeah, no? As you can see, there's no? Na mayroong protein, no, that is transport, farming, working, ulit siya, no? They hold that, all the membrane core, which is used to transport molecules from one side of the body to another. Hence, the cell membrane is a semi-permeable membrane, selected barrier, and it can transport drugs via several mechanisms. And there are different transport systems. So transport is the mechanism of drug movement across cell membrane, and there are different transport systems. We have passive diffusion, care-mediated, convective transport, ion pair, and pinocytosis. So, naku, alam namin yan, sir. Pero kailangan ko lang i-recall kasi ito, these basic concepts lumalabas pa rin talaga sa board exam. Hindi sila nagsasawa, no? And the basic requirement for a drug transport to proceed, it must be in the aqueous solution, no? Except if the transport is via pinocytosis. So number one, we have passive diffusion. So this is the dominant transport mechanism, but it is the slowest. So it is the dominant transport mechanism because it is non-energy requiring. So no ATP is required to proceed, for it to proceed. The governing principle is that the drug must be small and should be lipid soluble. Okay. And the movement of the gradient is from high to low concentration. So the driving force is the concentration difference. Pag mataas ang concentration difference from one side, mag-proceed yung transport. Parang ano lang yan, kunyari, isa lang yung tumutulak sa'yo versus 10 tumutulak sa'yo. Di ba? Mas malayo mo mararating mo. Ano, parang ganun lang siya, no? For it to proceed, dapat mas mataas yung reagent para mag-proceed yung reaction. And it is governed by the Fick's law, where dQ over dP or the rate of diffusion is equal to the diffusion coefficient, surface area, and partition of coefficient, and multiplied by the difference of the concentration in the GI area versus minus the concentration in plasma, and inversely proportional to the thickness of the membrane. So ito, familiarize nyo lang, no? Familiarize this equation. And there are several factors that affect passive transport. So, basing on the equation before, no, makikita nyo that it is affected by surface area. So then there's an increase in surface area, there's an increase in passive transport. Example, no, small intestine has a higher surface area than stomach. Therefore, mas mataas ang passive diffusion in the small intestines than the stomach. And lungs is the organ with the greatest passive transport. Kasi marami yan. Di ba saka-saka yan? And kaya mabilis, di ba? For example, yung mga asthmatic dito. Meron ba? So relatively, may mga pump, di ba? Kaya pagka, yung may mga controller, di ba? Kaya yung mga asthmatic, mas nire-recommend nila yung mga MDI, no? Through inhalation na mga powders, kasi nga relatively, mas mabilis ang absorption, no? Pagka doon yung yung route of administration. Rather than inject, inumin, ganyan, no? Kasi that's why lungs is the better parang route for yung mga intravenous mga corticosteroid. Amin ang sasalita. Ay, sorry. Wala pa lang. Next, concentration gradient. So nasabi na natin yan that there's an increased concentration gradient, there's increased rate of transport. So the thickness of the membrane. So pag maalala niyo yung equation, no? Alam niyo na yung sasagot, no? Pag nag-increase ang thickness, inversely proportional siya kasi, di ba, no? So there's a decrease in transport or the rate of diffusion. So the diffusion coefficient is a property of the drug in relation to the permeability barrier. It is a constant, no? And it is determined by, permeability barrier is determined by the particle size. So the smaller the particle size, the increase in diffusion coefficient. Since smaller particle can occupy greater surface area. And next we have lipophilicity of the drug, wherein there's an increased lipophilicity, there's an increased diffusion coefficient. Contributors in this lipophilicity is the degree of association or ionization, and drugs, no, if it is a weak acid or weak base. So, as a rule of thumb, no, in order for a drug to pass the lipid bilayer, it should be in non-ionized form. Ibig sabihin, pag non-ionized, no charge. No? And non-ionized form is the lipophilic form. Okay? So, kailangan no charge para magpasya sa lipid bilayer. No? Kaya di ba sinabi natin na drugs parang mangyayari, dapat miscible siya or soluble siya. No? Like dissolves like, no? For example, ang tubig hindi maghahalo sa oil, no? So, ang hahalo lang sa oil ay yung oil base, di ba? Ganun siya. So the effect of pH of environment on weak acid in solution is that weak acid exists more in a non-ionized form in a more acidic environment. So when it comes to tawag dito, parang drugs do, depende sa drug, di ba? Kasi sabi natin na depende din talaga siya kung weak acid or weak base. So depende sa pH yung property ng dissolution. So relatively kung kung weak acid, so ang gusto natin is non-polar, no? Non-ionized, no? Ibig sabihin dapat naka-expose siya sa more acidic. For example, aspirin. Aspirin is a weak acid, no? Kaya pagka mas na-absorb siya sa more lower pH, no? Kaya siya iniinom, no? So lower Ka or higher pKa, and yun nga, no? Weak acid exists more on a non-ionized form in a more acidic environment. So sa stomach siya na-absorb yung aspirin. Kasi nga relatively acidic, di ba ano bang pH na acid ng gastric juice, parang almost 1 yan, di ba? So since weak acid, yung aspirin mas absorb siya sa stomach more than the small intestine. Kasi sa small intestine mas basic, di ba? So ganun din sa weak bases, no? If there's a high Ka, lower pKa, therefore more basic pH. So for example, ano bang mga sodium bicarbonate, no? Sodium bicarbonate is a weak base, no? So doon, mas ma-absorb siya more sa small intestine. Kasi ang pH doon mas basic, no? Partition coefficient, on the other hand, is the ratio of solubility of the drug in oil to its solubility in water by lipid water partition coefficient. So it is computed as the lipid solubility over water solubility. Therefore, if there's higher kumbaga, para maging favorable in passive transport, it requires higher partition coefficient, no? Kasi relatively, it must have a higher lipid solubility than water solubility. Okay, next. We have carrier mediated transport. So these mode of transport requires a carrier molecule, parang taga-sundo, no? Or shortcut, no? So dito, tingnan nyo dun sa screen, no? So yung passive transport, it requires a smaller particle. Kaya kahit makikita yung space, no? Passo na nakasigil siya. So that is passive transport. Pero pag medyo larger na molecule, no, it requires a carrier, no, para makapasok siya from one point to another. So there are proteins, no, in the cell membrane that can undergo conformational change due to this step. So these are carrier molecules. So and carrier proteins, no, can cater both passive and active transport, no? So pag active transport, it requires energy, no? Ibig sabihin, it requires ATP for it to proceed. So the difference of these two is that in active transport, it requires energy. Facilitated diffusion, it is a non-energy requiring transport. Pag active transport, So relatively, parang, di ba pag non-energy requiring, downhill siya from downhill meaning from the level of high concentration to lower concentration. Okay? Pero pag active transport, pwede nang from lower transport, lower concentration to higher concentration. Parang lang yan pag sumakay ka sa sasakyan, no? Tapos aakyat ka sa hill, no? Kailangan mo ng gasolina para maakyat ka yung sa hill. Pero hindi yun gagalaw pag natin ka wala kang gasolina, di ba? Pero pag pababa ka ng hill, kahit sarado yung sasakyan mo, bababa yun by the pull of gravity. So that is, kahit wala kang gasolina, naubusan yung gasolina, babagsak ka sa ibaba. So that is yung uphill versus downhill. Sa mga hindi alam yung term na yun, no? Pero pwede kasing gamitin yung ganong concept. And the different active transport naman is the fastest, no? So kung kanina yung passive transport is the prominent, no? So it is the fastest naman yung active transport since merong energy. Carrier-mediated transport is that it transport across cell membrane by protein carriers that is specific, competitive, and saturation. It is saturated, no, yung mga protein carriers. So specificity, it means that it interact to one specific molecule only, no? Second is competition. It interacts with the molecules with the similar structure. So ito yung parang kamukha, no? Na-identify na parang same naman sila. So parang okay, papasukin natin. So that is competitive. And saturation is that if the carriers, all of the carriers are filled ng new molecule for transport. Para lang pag puno ka na, ayaw mo na. Ba? Tama na, ayoko na. Ganyan yung may napanood ako na vlogger, yung parang, siya, nag-acting siya, tapos, wala lang, share ko lang. yung bigla siyang gigisingin siya, tapos sasapalin na siya ng nanay niya. Mag-acting na. Hindi ko alam kung napapanood niya yan. Wala lang. Usually kasi pampagising ko yung Facebook feeds. Pero hindi ako nag-TikTok, hindi ako yung mga not in my generation. Parang okay. So ito, for example na lang, no, we have isoniazid and vitamin B6. So sino yung mga TB treatment dito? Meron ba? Who would like to share? Okay. Pero yan nga, siyempre medyo mahihiya. I myself, no, nag-TB treatment ako before. Pero hindi ko alam paano ko nakawa or what. Dito sa Maynila, no? So, pharma days ako noon, sobrang depressed, kala ko katapusan ko na or what. Yeah, 6 months. Ang hirap pala talaga no, ng TB treatment. So, hindi ibig sabihin payat. Hindi ibig sabihin payat kasi dati payat pa ako. Oo guys, payat ako dati. Nung student ako na, like you. Hindi ibig sabihin na mataba or what, hindi nagka-TB. Pwede rin yan magka-TB. So, isoniazid is part of the first-line drugs for TB, no? Kung naaalala, no? And vitamin B6, usually binibigyan natin yan ng B6, no? Yung mga B-complex, kasi nagka-cause yan ng peripheral neuropathy. No? So relatively, kaya yon kasi ano nangyayari, nagkakaroon ng depletion ng carrier, no? Kasi na-occupy ng isoniazid yung para sa B-complex. No? So ano nangyayari, nawawala, kaya tayo nagsusupply ng B vitamin, no? Para hindi magkaroon ng peripheral neuropathy. Nagkakaroon ng competition between the receptors ng natural B vitamin natin over isoniazid. And for that, na kasi relatively they have the same, they compete with the same carrier. So ang gagawin natin is to supply more B vitamin, like vitamin B, specifically vitamin B6 para ma-display sila doon. Para hindi magkaroon ng peripheral neuropathy. Amazing, no? Bakit? Sabi ko, bakit ako ang dati na, bakit kaya mag-BB complex ba, dami-dami iniinom. Pero yun pala yun, no? So, second, we have digoxin and quinidine. So, they inhibit they cause inhibition of the carrier for tubular secretion and predispose to digital toxicity. Kasi, ang nangyayari, no, digoxin doubles the therapeutic doses of quinidine. Therefore, it decreases the renal clearance of digoxin. No? That's why, hindi siya binibigay on the same time as the patient. Hindi siya binibigay at the same time sa isang patient. No? Next, saturability, like we have different kinetics. So first order, and zero order. So pag first order kinetics, limited number of carriers. Therefore, when the rate goes up, as the concentration goes up. Pero pag zero order, even though there's an increase, there's an increased number of carriers, no, the rate does not go up. So we will further discuss that. We will further discuss it later. So there are times, no, that yun nga, at low dose it becomes a first order reaction, but at the high dose it becomes a zero order where it reaches saturability. So that is saturable, capacity limited on linear or Michaelis-Menten kinetics, no? So at the first dose or at low doses of drugs, it is on the first order. But if it is saturated already due to the limited number of proteins and carriers, it becomes parang no effect na, no? It reaches its threshold. So, papasok tayo sa rate kinetics. So, zero order is the rate of reaction that is independent on the concentration of the drug given. So, kung maalala nyo, ito yung reaction, computation natin. Concentration is equal to the dissociation constant, temperature plus the initial concentration. And kung maalala nyo, hindi ko alam kung nagsasubject pa ba kayo ng calculus. Nagka-calculus pa rin ba kayo? Hindi ba dinerive kung ano na to? Usually, dati naalala ko ng student ako, tinatandaan ko lang yan, tapos diniderive ko na lang para hindi ko nakakabisa dulo ng nerves. So, para maging first order siya, di ba linear equation. Pero hindi ko na ituturo, hindi na yung kasama. Okay. So, we'll practice one computation for zero order. Okay. You have your calculators on you. Wala kang calculators. Kahit simple cellphone na lang. Para matesting na lang. So, a suspension decays by zero order kinetics with a reaction rate constant of 0.5 milligram per ml per hour. What is Diana? What is the concentration of the drug remaining after 3 days? So pag sinabi na natin zero order, it doesn't decreases over time, no, yung concentration rate, no? So steady lang yan. Ibig sabihin, meron ba tayo consuelo? So, basta, kumbaga, yung rate niya, kunyari ganyan, after 5 minutes, gano'n na rin yung rate. So, same lang, no? So that is zero order, no? Kung 5 milligrams yung nabawas after 1 hour, 5 milligrams din on the second hour. Every hour, same lang. That is zero order, no? Constant. So what is the answer? Using that computation, sa mga TFC subscribers, sir, yung mga students ba nasa isang room lang din sila? Sir? Or nasa bahay lang sila? Yung mga nasa ibang lugar? Depende sa school. Okay. So, yung sa mga gusto mag-participate, feel free na ilagay yung answer niyo if you want to verify if it's correct. Anyone, may nakasagot sa inyo. Dapat meron kayong laging calculator. Diba? Hindi may gusto po parma, wala calculator. Pero sa mga susunod, wala na. No? Pero sa introduction kasi part pa rin siya ng introduction natin. Anong sagot natin? Anong sagot ninyo? So, mga calculator. Okay. Meron lang parang guess lang. Kahit try lang. Sino yung try? Naalala ko dati ng student ko. Share ko lang. Yung teacher ko nagagalit sa amin pag hindi niya naririnig na yung calculator, di ba sa scientific calculator? Pag hindi niya naririnig na tumutulog yung calculator namin pag ng mga As in, ewan ko may gano'n kayong professor, pero grabe talaga, parang gusto niya tumutunog talaga. Sabi ko, yung calculator. So, anong sagot natin? Uy, dapat mabilis kayo mag-calculate pag board exam. Ilan ba sa isang 1.5 lang? So, isang module? Parang 2 hours. Diba? 2 hours, so 60. Tapos 100 items. No? So, more than 1 minute lang kayo sasagot per question. So, dapat mabilis kayong mag-enter. Kasi, ang sabi, sa board exam daw, merong last time na pinagbawalan ng mag-calculator, tapos biglang lahat pinagbawalan, parang ganun. Recently, oo, pero kasi wala pang official talaga kung talagang hindi na magka-calculator. No? Pero kasi ang sabi daw, parang may nagkamali na isang testing center or parang ganun. So, kasi nakalagay naman talaga yun na nagka-calculator. So, I don't think bigla nilang tatanggalin yan. Kasi by nature, pharmacist, magaling mag-calculator. So, wala na? O sige, kung medyo nalolost kayo kasi wala rin yung pa-participate sa TFC subscribers. I don't know kung nandyan pa kayo. Nandyan pa ba kayo, guys? Okay. So, ang mangyayari dyan, ano ba yung naging sagot? Kasi walang rate constant, yun, KOP. 3 days time, 3 days. I-convert nyo lang to time. Wala ba tayong kahit ano? Wala kasi tayong So, para mapakita ko paano natin ito-compute. Meron ba kayong Kasi may eraser tayo. Wala tayong pansulat. Hindi niyo ba nakukuha? Hindi niyo na-gets? Paano nakuha? Tama kayang sagot? Tama yung sagot niyo? Or medyo nalito kayo ba? Ano nakuha yan? Kasi ang gagawin niyo, di ba in days siya? After 3 days, di ba? So di ba dapat para mag-solve kayo, dapat i-add yung time. Hindi kayo magsasagot na 3 days times 0.5. Hindi. Kasi hindi nyo makakancel eh. Naka per hour. Ayan. Para mas malinaw kung may sulat. Diba? See? Concentration is equal to yung constant plus the initial concentration. So, ang given 0.5 milligram per milligram per ml per hour times 3 days. And you guys are on 3 days. 1 day, 24 hours. Okay? So, makakanta naman. Okay? Plus, yung concentration natin na 125 milligram per hour. Milligram per ml. So ito, 0.5 times 3 times 24 is 72. Good morning. So ito times 0.5 is 36. So here ito 36. Plus 125 milligram per ml. 89 milligram per ml. Diba? Baka may nahihiya lang mag-raise ng answers. Medyo nalito lang. Okay. Ayun, maliit pala. Parang nangyari na dagdag palalo, parang ganun. So, okay. Hindi namin po makita. Ito, ayan. Paano ba natin, ito pakita ko yung... Paano ba ito patanggal, sir? Ito tanggal. Papakita lang natin. Ilapit mo lang sir dito. Di ba, sir, ngayon ng part lang ako may pa-computation dito. Sorry for the benefit ng yung pooling natin.
Kita kayo dito.
Ayan.
Kita na ba guys?
So, sinubulan lang yung So, kailangan kasi per real time hours para ma-cancel nyo yung hours, no? Kasi, so substitution natin, ang tanong kasi natin dun sa questions, ano yung concentration after 3 days So what is the demonstration? It follows in order in graph. No? So negative, so initial, the concentration is equal to the negative of the constant times the time plus initial concentration. So negative 0.5 gram per hour. In gram per hour. No? Ilan pa sa isang araw, 12 hours before. So 3 days. So nagkalagay dimensional analysis. So para ma-cancel natin yung days, 2 hours. Yung hour, magpa-cancel na natin yung sa constant. No? Plus, yung concentration. So, gagawin lang na parehas sila na combine. So, negative 36 plus 125, we will have 89 milligram per minute. So, sorry, wala na sir. Sige, wait lang. Isa-set up sa PowerPoint. Sir, okay. Hello. Yeah. So, mas malinaw na. So, nangyari. Yan, tinayin ko na lang tapos cancel na lang. So, mangyayari, maka-cancel 2.5, negative 0.5 milligram per hour times 3 days, no? So, we can cancel 3 days, no? In an instant. Kaya ika-cancel ko convert. Mag-ito po, sir. Hello. Kasi natanggal. Sorry, wala na technical issues. Yan na. Okay. So, negative 0.5 times 3 days is 3 days, hindi natin siya maka-cancel. So, we need to convert it to hours. So, 3 days times 24 hours per day yung ating converting factor. So, para mag-save nila. So, 0.5 times 3 times 24 is negative 36. Pa rin daw. Yun yung best natin. Tapos, plus 125. So, magiging 89 milligram per minute. Mag-i-echo pa rin daw. Ayan. Hello? Mas malinaw na? Ano yun? Mas malinaw, kanina mas malinaw, tapos ngayon may echo. Naka-on yung laptop. Okay. Hello, ayan. Mas okay na? Yan, okay na po, sir. Ayan. So, malinaw na to ha. So, pwede na tayo mag-move on. Okay? So, pakikunan na lang ng picture, then let's proceed na. Kasi medyo mahaba pa yung natin. So, next is the first order kinetics. So, it is dependent on the concentration of the drug remaining, no? So, it is technically yung ano natin, para maging first order kinetic siya, dinerive lang yan by a logarithm, no? Pero it can be present so kung hindi man nyo kayang i-derive, medyo mahirap naman talaga kasi yon. So, yan, i-familiarize nyo na lang yung conversion. Pero relatively, no, by experience, ang tinatanong na lang sa half-life sa board exam. Pero, hindi natin alam. Depende sa board examiner, sa pop-up nila. Pero you can memorize, no, yung mga following equation. They work at the same lang. Pare-parehas lang yan. So, another example na ko. Sige, tingnan natin. An ophthalmic solution of a mid-reactive drug at 5 mg per ml exhibits first order degradation with a constant of 0.0005 per day. How much will remain after 120 days? So, sasabihin naman yan sa inyo kung ano yung order of reaction. So, using the third equation, no? LNC is equal to the negative 0.005 per day times 120. No? So, ang mangyayari niyan, after nyo makuha niyan, get the reverse, tawag dito, get the reverse, LNC, it is equal to 1.55, then get the reverse of the inverse LN. So by clicking shift LN, you will get 0.71 milligram per ml. Kaso, meron ba sa iPhone? Meron ba sa mga calculator? Wala sa inyo may ano? Kaya naman. Sabi ko, sabi ko. Ewan ko ba, kahit nung parang part na ng buhay ko yung calculator, kaya dapat kayo din, part din ng buhay niya yung calculators niya. Yan, meron naman pala, nagsiselfone, meron palang meron dala, para hindi kayo nahihirapan. O sige, try nyo. Kasi alam nyo, minsan, nakakasagot kayo by muscle memory. No? Yan. Nakuha niyo na? O iba yung nakukuha niyo? Ayun, 1.71, 4.7. Kuha niyo na, guys. And then, hindi siya minus nga pala. Sorry, may typographic na lang. Ano ba yan? Diba? Dapat plus. Ilagay ko na lang yung first. Ayan, guys. So, yan yung initial reaction nila. Initial equation. LNC is equal to negative KT plus Ln of the initial concentration. So, i-substitute natin yung values, no? So, yung constant is negative at the product of 0.005 times 120, no? Canceling yung day, time plus Ln of 5. Yung 5 is the initial concentration. So makukuha nyo yan is 1.55. Ln, tama diba? Then, baka hindi nyo nako-consider yung negative. Negative. Kuha na. Tapos, LNC is equal to 155. Until i-inverse LN nyo siya. So, gagawin nyo yan, inverse LN, pag ma-inverse LN is shift LN. Then, equals. Kaya mas maganda ganito. Yung calculator. Kuha na? May nakakuha na? Okay. Okay na. Ha? Continuous. Hindi ako parang pinakita ko lang yan. Pero huwag nyo nang i-round. Dire-diretso na sa calculator. Usually naman sa ganyan, dire-diretso ang computation. Hindi dapat nira-round up or nira-round down in the middle of the computation. Okay? Another concept is half-life. So it is the time it takes for the drug concentration to decrease by 50%. So if there's the drug is zero order, half-life is equal to 0.5 initial concentration over the constant. Pag first order reaction, half-life is equal to 0.693 over K. Siguro ito, mas maraming comment ko na mas i-memorize mo. Kasi sa board exam, yan lang yung tanong. Minsan, first order reaction tinatanong dyan. Most common. Kasi napakadali lang i-memorize 0.693 over K. Okay? Okay. So, medyo siguro nagising na kayo doon sa ating energizer. Okay. Next, we have convective transport. Convective transport is the movement of water, filled pores or channels. And it has specifications like the pore size or diameter. It is in 7 to 10 angstrom that allows the molecules or ions with molecular weight less than 150 to 400. The charge of pore lining allows movement of ions with charge opposite to the pore lining. And the movement is by solvent drag. Meaning ions move along with the same direction as water, and the movement is along an electrochemical gradient that takes into consideration the net charge of the concentration gradient ions. If there's a greater concentration gradient, there will be movement, no? So next is ion pair transport. It is the movement of large ions. For example, yung mga exogenous large cations like quaternary ammonium compound and using in GIP, no? That it creates a neutral electrophilic complex to move as a passive diffusion. So, di ba, as I've said a while ago, kailangan, para makamove sa lipid bilayer, kailangan non-ionized. So, for this, no, kasi yung mga large cations natin, they are charged, no? And usually, ang magko-combine naman dyan para maging neutral is positive and negative. No? So, combine that ion and an anion forming an ion pair which is neutral. So therefore, non-ionized and can penetrate the liquid bilayer. Then once inside, they will dissociate to perform their different effects. No? Next is vesicular transport. So it is a general term which is the evagination of a cell. Cell membrane, and it is based on the type is based on direction, like endocytosis. Ibig sabihin, papasok, papasok, no? So we have pinocytosis. So pinocytosis is cell drinking, no? Therefore, it is in the form of liquid na papasok. Pag phagocytosis, it is solid, it is cell eating. Pag exocytosis, ibig sabihin, palabas. So, pinocytosis or cell drinking, it is vesicle mediated and it requires a micelle form of the drug which is a energy requiring. Micelle, ibig sabihin nun, it forms parang i-covering, no? Yung, di ba yung parang yung naka-enclose na lipid dun sa drug, micelle, no? Parang yun yung magiging transporter niya, no? Para siyang nasa bubble, no? Tapos yung organelle or yung substance may nakabalance sa kanya para makapasok siya. Kasi yung micelle, ang background ng is a lipid. Kasi ano nangyayari, sir?
Ito po talagang ginagamit namin sa online.
Ito talaga.
Maganda kasi siya sa LGDL.
Okay, sige.
Nag-break na po.
Hindi pa. Magbe-break lang saglit kasi ayusin lang natin yung mga PowerPoint. Ililipat na lang yung file. Okay. Okay. So, pag-aaralan namin later yung ano, pero kung pag-aaralan namin later yung system on how paano makokonect yung cells, yung speaker namin using the Zoom later, no? But we'll proceed with the lecture. Siguro naman napag-merienda ng lahat, no? Sige, but we can continue, no? While siguro working, ano na lang tayo. Para matapos natin yung first, at least yung first part. Okay. So, pinocytosis is used for the transport of large lipids like yung mga lipid vitamins natin like yung ADEK, vitamins ADEK, no, and resilopoldin. And these are given with a high with a fatty meal, no, pwedeng milk, pwedeng basta matataba, no, which stimulates the release of cholecystokinin that causes the gallbladder contraction to release bile acids. And these surfactants will be used forming micelles, no? So these micelles will transport resilopoldin. Familiar kayo sa soap? Di ba minsan pag kanyari nilagay niyo mo ng soap, mabubura siya, mawawala siya. Yun yung micelles. Yun yung ginagawa ng parang surfactants. No? So yun. Para siyang soap. So liberation. So let's move on to the yung process of ano yung parang fate ng drugs, no? So first, once na-intake natin yan, no, it undergoes liberation, yung drug, no? So liberation is the release of drug from the dosage form or drug product, and the end product must be in the aqueous solution, which is the primary requirement, except, no, pag yung mga per orange solution, like tablet, no, at saka yung mga syrups, elixirs, since it is already in the liquid form, there is no more liberation. Kasi liberated na siya in an aqueous solution. Okay? So there are factors affecting liberation. Number one is pharmacotechnical. So these are factors that are inherent to the drug product. It is consequence of formulation and quality that is built in the product. So doon papasok yung mga disintegration, di ba? May mga disintegrants tayo, iba-ibang disintegration, iba-ibang dissolution, mga ganyan, no? Depende sa mga excipients and properties of different formulations. That is pharmacotechnical. For example, yan, tablet dosage form. So different tablets has different hardness, disintegration, and dissolution properties. And liberation is highly modifiable process. So that's why currently meron na tayong mga modified release drugs, no? Alaxan FR. Di ba, mga ganyan? Di ba? Ano pa ba? Muse, mga parang yung mga pang good for 24 hours na mga ganyan, di ba? Long acting. Di ba? Mga ganun na. So, yun, no? Pero mamaya i-define natin yan. And there are different routes of drug administration. It can be parenteral. So, parenteral includes intravenous, intraarterial, intracardiac, intramuscular, subcutaneous, intraarticular, intradermal, intrathecal, intraspinal, epidural. Yung student ako, sabi ko, paano ginagawa? Pero talagang possible pala talaga yan, no? And it requires yung mga specific expertise, pag for example, intrathecal, no? Ibig sabihin, dito na sa spine, no? Mga ganyan, no? So relatively, it requires specific skill. Enteral, so ibig sabihin feeding, so it can be buccal, sublingual. So yung buccal dito sa ilalim, di ba, dito? sa bibig. Pag sublingual, under the tongue. Pag per oral or oral, so and rectal. And respiratory by intranasal or inhalational. It can be skin through intransdermal or percutaneous, or it can be topical, and others we have ophthalmic, otic, urethral, and vaginal. And it is seen that IV or intravenous is 100% bioavailability by definition, and it is considered as the most rapid onset. Pero hindi naman kasi lahat ng drug kailangan IV lang, no? And maraming patients ayaw niyan, no? So it can be intramuscular, for example, mga vaccines, no? Sino ba na bivalent na dito? Wala pa. Ako, syempre meron na. Pero, syempre, pag mga health professionals, no, nababivalent. Pero meron bang anti-vaxxer dito? Dapat hindi. No? Meron na kayong booster requirements sa school nyo. No? So, yeah. It can be subcutaneous. So, ano mga subcutaneous na bibigay? Insulin. No? Yeah. Oral. Majority naman, no? Mga tablet. It is the most convenient and first pass effect may be significant. So, mamaya explain natin yung first pass effect. It can be rectal. So, ano ba mga rectal? Suppositories, no? Yan, mga, siguro nung bata kayo, na suppository kayo ng bata kayo. Inhalational, no? So, 5 to up to 100%. It is often the rapid onset dahil nga sa large surface area. And transdermal. So usually yan yung mga patches, no? Pwede. And many more. So meron tayong mga tinatawag, no, due to the evolution of science, no? May mga targets tayo, may mga drugs tayo that we modify to improve compliance. Ang dami naman puto, dami iniinom. Ano ba yan? 4 na beses araw-araw, hindi ko nakakainom. Hindi ko nga nakakaisa lang na iinom ko araw-araw kasi busy. Nako, yun nga, sa totoong buhay, ang daming busy, no? No? Mas busy pa sa inyo, mas busy pa sa lahat. No? So, yung mga patients, gusto nila isang inuman na, mga ganyan. No? So, we create, na-create yung mga modified release tablets or mga meds, no? For example, immediate release. So these drugs are released, drug is released immediately after administration. Gusto po instant, meron na pong effect. No? So yun, kaya immediate release. Tanggal agad ang sakit ng katawan. Alaksan FR. Fast release, immediate release. O, diba? Next, we have modified release. The drug release occurs sometime after administration or for the prolonged period of time for a specific target in the body. So it can further... So it can be further divided into extended release and or delayed release. So pag extended release, the release prolongs the release to reduce dosing frequency. For example, yung kalahati ng may mga tablets na kalahati ng tablet lang yung initially madidisintegrate, tapos yung kalahati ng tablet mamaya pang hapon or mamaya pang gabi. No? So therefore, dosing frequency is decreased. Next, we have the delayed release. So the drug is released only at some point after the initial administration. So depende rin yan, no? So depende sa target, no? So I mean, pag extended release, mahaba yung time na nare-release siya para unti-unti, no? So relatively buong araw covered ka, parang ganun. Pag delayed release, mamaya pa yung next dosing. Parang, sorry. Pagpalit ko. So for pharmacokinetics, so pharmacokinesis, Kinetics means from kinesis means motion or change in rate. It is the fate of drugs in the body. So di ba parang the most common naman na algorithm dyan is kinetics katawan. No? Anong ginagawa ng katawan sa drug? Yun yung pinaka ano, no? And it is the principle include absorption, distribution, metabolism, and excretion. Absorption, how will it get in? Paano siya ma-absorb? Yun ang number one, no? Number two, distribution, where will it go? Metabolism, how it is broken down, and lastly, how does it leave, no? And all of these pharmacokinetics are crucial, no? And it can vary management, no? Na patient to patient, no? So there are different mga first lang, no? Elimination is the combination of metabolism and excretion, while disposition is the combination of distribution and elimination. So parang lumalabas yung disposition is DME, no? Distribution, metabolism, and excretion. No? On the other hand, dynamics means power. It is the biochemical and physiological effects of the drugs. So what the drug does to the body, no? So merong receptor, kung may ginagawa yung katawan doon sa drug, meron din ginagawa yung drug sa katawan. So there's a two-way relationship. And pharmacodynamics is governed by two laws. So first is the drug receptor occupancy law, or the law of pharmacodynamics, which is highly specific and highly sensitive. It means that combining the drug molecule with a receptor, which has an affinity, and the initiation of pharmacological response by intrinsic factors. So, ibig sabihin, a drug must have a receptor, no? Para magkaroon ng effect or to transmit its effect, no? Or kumbaga marilay niya yung effect. Spare receptor theory tells us that if there's an increase in receptors, the drug concentration decrease in the blood or in the circulation. Kasi ano nangyayari, it is not available in the circulation kasi naka-attach na siya sa drug, sa receptor. So kung makikita niyo doon sa taas, no? Ayan, yung second picture yun. So relatively, nakakonect niya yung mga drug dun sa receptor. Kaya less na yung mga nakakonect nasa available sa circulation. So the receptors are said to be spared for a given pharmacologic response if it is possible to elicit a maximal biological response at the concentration of agonist that does not result in occupancy of full complement of available receptors. So nasabi na natin yan, no? So by the physiological definition, absorption is the rate and extent of disappearance of the drug from the site of administration. So ibig sabihin kung oral, o wala na siya sa bibig, no? So that is absorption. Or kung saan siya na-administer. No? So ang goal natin dyan is for the drug to be transferred to the lumen, to be transferred also to the bloodstream, no? So doon ang goal natin. Lahat yan magpunta sa bloodstream para makapunta sa target organ. Pharmacokinetic definition is the rate and extent of drug entry into the systemic circulation. Parameter measured include bioavailability. It is a measure and extent, rate and extent of drug entry into the systemic circulation. And there are two ways to determine bioavailability. It can be using the drug plasma concentration versus time graph shown below ng label, and the other one is the accumulative urinary excretion data sa ibabaw. So ito yung on the left side of your screen, no? we are using blood dito, no? Blood concentration. Whereas dun sa kabila, hindi na siya masyadong ginagamit kasi it uses urine, no? To determine the concentration of the amount of drug excreted. And there are three important bioavailability parameters. We have Cmax, Tmax, and AUC. Cmax is the most variable parameter, while Tmax is the time to reach the concentration maximum, wherein the measure of rate only. And the most important is the AUC, which is the measure of the extent only, and consider this as the most important bioavailability parameter. Area under the curve, no, as I've said a while ago, it is the measure of amount of drug in the body. It reflects the total amount of active drug, and it measures the extent of drug bioavailability, no? So lahat ng nandun sa curve, ibig sabihin yun yung concentration, no? So Cmax, so the one in your x-axis is the time, no? And the one on your y-axis is the concentration. So yung area under the curve reflects yung concentration ng drug na nasa systemic circulation. Okay. So also we have the plasma curve, the plasma time curve, and there are different terminologies, no? So number one, we have the minimum effective concentration. So nasa handout niyo yan, no? It is defined as the minimum concentration of the drug plasma required to produce a therapeutic effect. So ayan. Pala may mouse pala tayo. So this one, yan. It is the minimum effective concentration, no, at this level. Ibig sabihin, nito, para basahin lang, para pinakita ko lang to, para alam niyo paano basahin. No? So at 10 milligram per liter, so there's a minimum effect, no, of the drug. So that is minimum effective concentration. Pag maximum safe concentration, it is also called as the minimum toxic concentration, or the maximum tolerated concentration is the concentration of the drug above the adverse effect, or unwanted effects are precipitated. So dito naman daw yun, no? Minimum tolerated concentration. So dito yung pinaka lower threshold. Pag sinabing onset of action, it is the beginning of the pharmacological process. So dito naman tayo sa time. Pag sinabing onset. So dito sa graph na to, no, nakikita natin na at 0, ayan. So this is the onset, no? This one. Pag sinabi namang onset time, so this one. Yeah, so dito pa rin 0 din at time 0 din is the onset of time. No? It is the time required for the drug to produce pharmacological effect. Pag sinabing onset time pala is, what I mean is this one pala. No? The one na na-reach niya yung dito lang, sorry. Ano ba yung nalilito? Ang hirap, hindi ako makagalaw. So this one, no? So the time na ma-reach ng curve yung minimum effective concentration. So at this graph, nasa first hour siya, no? As you can see dito sa ating cursor, ayan, tapat-tapat doon. Dito siya dito sa green, no, yung green. Pero kasi itong red, medyo malapit. No, parang kalahati pa ng one hour. nag-start na siya, no? Nag-pass na siya ng minimum effective concentration. The blue line, hindi siya nag-merge doon sa minimum effective concentration. So wala siyang, hindi siya nag-effect. So yan, onset, no? Pag sinabi namang duration of action, it is a time period which the plasma concentration of the drug remains above the MEC. So this one, up to this one. So ito yung time na yung curve nasa ibabaw ng minimum effective concentration. That is the duration of action. So from this one up to this one, dun sa green graph, that is the duration of that compound, no? So technically para nasa ano siya? Parang 9, 8 and 9.5, no? Minus 1, so 8 hours, almost 8 hours yung duration of action. And lastly, the intensity of action is the maximum pharmacological response produced by the peak plasma concentration of the drug, also known as the peak response. So dito naman is the intensity. It is the level of concentration, minimum effective concentration up to its peak. So relatively, ang peak dito nasa may almost parang 18, no? So technically, at ano siya, between 10 to 18, yun yung intensity ng drug, yung compounded. So important alam nyo paano magbasa ng graph kasi ngayon, nung time namin makinilya yung yung exam. Pero kasi ngayon, medyo marunong na sila mag-computer. So hindi na demand makinilya pwede na maglabas ng plasma curve. O sabihin, ilang hours ang peak response, ganyan. So marunong kayo paano basa. So ito naman, magkaiba to dun sa graph kanina, no? Kasi ito naman is in logarithmic form. Once in your the one in your left x-axis is the logarithm of drug concentration versus the patient responding. Yung y-axis natin is the patient responding to the treatment in percentage. So magkaiba sila. So the difference between the maximum therapeutic, minimum toxic concentration and the minimum effective concentration is the therapeutic range, no? And therapeutic index is the division of PD 50 over PD 50. Ibig sabihin, yung PD or the therapeutic dose in which 50% of the population toxicity, which is this one. So at 50% na nagkaroon ng toxicity at saka 50% na nagkaroon ng effect. That is therapeutic index. So magkaiba yung range, no? Yung range, ito yan. This one at saka this one. So dito, pag sinabing therapeutic range, no, it is in between this one at saka this one. Okay? Pero pag sinabing therapeutic index, iba yung graph nun, and it pertains to the population under toxicity at 50% and population effect at with effective result, no, at 50% of the population. So it is the basis, therapeutic index is the basis of margin of safety, you know. Pag hindi ko kasi masama sa handout, no? So pakisulat na lang na margin of safety. If the margin of safety is or the therapeutic index is greater than 10, it is generally safe, no? Pero pag narrow margin or less than 10 yung therapeutic index, it must be used in potion. So for example, ng mga may narrow therapeutic index, we have digitalis, mga barbiturates, no? So that's why pag mga ganyan, we are very careful, no? Kasi relatively, they are prone to have adverse effects and toxicity when used in differently, no? There are two types of bioavailability. We have the F absolute and the F relative. So F absolute is it is equal to the AUC of the test drug produced given non-IV over AUC of the drug in the same dose IV. So in this type of bioavailability, IV form is the reference, no? Whereas in F relative, it is the AUC of of the product non-IV versus the AUC of the non-IV drugs of the same dose. So dito naman, the reference is the innovator product. So example, kung kunyari may IV, for example, meron kang bagong omeprazole, no? Omeprazole capsule. So you want to cross-reference its bioavailability. Example lang naman to, no? So ang mangyayari, you will use the IV form of omeprazole to test, no? To test if it is bioavailability. Pero for example, amlodipine wala namang IV form. And for you to check its bioavailability of your product, for example, nagawa ka ng sarili mong amlodipine, no? For you to check that bioavailability, you will use the innovator Norvasc. No, Norvasc is the innovator of amlodipine. No, so to test its bioavailability and to compare your product to the innovator. Okay, that is F relative. Ito ano lang yan, sample computation na. So there are also bioequivalent drug products, no? So these are pharmaceutical equivalents that are similar bioavailability when given in the same molar dose and studied under similar experimental conditions. Bioequivalence is established when two drugs have the same bioavailabilities. Ibig sabihin nun, in statistics, ANOVA and TERT test, there are no statistical difference. No? Familiar naman siguro kayo dyan kasi nagre-research kayo. No? And there are different approaches. We can do in vivo pharmaceutic studies, including blood and urine. Diba? Compare mo kung ano yung concentration ng dalawang daga, for example. No? Kung parehas silang kung parehas silang nakikita sa dugo ng daga or ganyan. Or it can be in vivo pharmacodynamic studies, comparative clinical trials, and in vitro comparative tests. So usually it is important regulatory requirement. Sometimes if you have a drug na new to the market or parang natapos na yung patency ng isang large company, gusto mo rin gumawa ng sarili mong ganung gamot, you will apply for bioequivalence. And also it is a marketing tool, no? Sabihin mo na, yung gamot namin, same lang din sa innovator drug. Kaya lang mas mura kami. Kaya sa amin ka na. No? So makaka-relate din may mga companies, may mga pharmaceutics, no? No? May makikita kayo na 100% ganyan. If similar effect, no, to the innovator drug and ganyan. Mas mga right net, di ba? Parang kiniklaim nila na parang same lang sila, gano'n. Sorry, baka may ari pala ng white. Sorry po, no? Baka mamaya maso tayo dyan. So relatively yung mga ganong mga instances. No? It is a measure of similarity of bioavailability of generic drug product to the bioavailability of the reference innovative drug product. Kasi relatively, pag natapos ang patent ng isang product, anyone is free na pwedeng gumawa niyang sarili nilang formulation. Pero hindi nila i-disclose yung formula nila. Bahala na kayo mag-formulate kung anong gusto nyong excipient, ano ang gusto nyong ilagay, no? But you're free to do whatever. But in general, or by theory, or technically, no, dapat bioequivalent sila. If they contain, kung 500 milligrams of paracetamol, 500 milligrams of paracetamol din talaga yung kanila. Ganun siya. Yeah. For example, rifampicin compared to Rifadin, no, which is the innovator of rifampicin. Diverside compared to Diamicron MR. So Diamicron MR is the innovator of glycoside. So we can measure, no, yung mga important bioavailability factors natin like AUC, Cmax, and Tmax. And based sa USP, no, that similarity must be established if each of the ratio fall between 0.8 to 1.25 or 80 to 125% at 90% confidence interval and should perfectly fall within the range. So for example, no, the generic drug A bioequivalence studies shows an AUC ratio of 78 to 120, Cmax of 81 to 126, and Tmax of 80 to 120. So so sabi nga natin, di ba, 80 to 125, no, yung range, no. So dapat ang criteria, it perfectly fits the criteria. So dahil nga hindi siya nag-fit sa AUC ratio, no, at saka dito sa Cmax ratio, generic A is not bioequivalent to the drug, no. Therefore, hindi sila parehas, no? So another is the biopharmaceutical classification system. It is a scientific framework of classifying drugs based on the aqueous solubility and intestinal permeability. Sir, pwede po ba paulit yung margin of safety? Basta sinabi lang natin na pag ang therapeutic index is greater than 10, it is relatively wide, therefore relatively safer. No? Pero pag sinabi natin na therapeutic index is less than 10, no? Relatively it is narrow and it is prone to dangerous side effects, no? For example, yung mga digoxin. They are known to be of narrow therapeutic index. So ito, pakitandaan lang to yung biopharmaceutical classification system. No? We have on your x-axis is the water volume required to dissolve the highest dose in ml, and the one in your right, in your y-axis is the permeability. No? So BCS1, these are compounds that normally dissolves in the gastric and intestinal fluid. No, so they have the they have high solubility and high permeability. So technically, no, sa mga class 1, hindi na nila kailangan ng bioequivalent studies, no? Next, example niyan is pregabalin. Sa classification 2, no? Class 2 ng BCS, it has low solubility and high permeability. So example niyan is clopidogrel, no? So the rate limiting step for absorption is poor solubility. So therefore, yung mga formulation, ina-adjust natin to overcome solubility and dissolution rate problems. In case na sa mga clopidogrel formulations, no? So relatively ginagawa niyan, ginagawa ng salt or ginagawa ng mga complexation, lipid formulation, and etc. for it to be more soluble to the to make it passable, no, sa intestines or sa stomach para ma-absorb. So dapat in a lipid form siya. So yan. Class 3, it has high solubility but low permeability. So dito naman ang problem natin is diffusion. Passive diffusion is the rate limiting step. So sa BCS2, ang problem natin is solubility, no? BCS3, ang problem natin is permeability. So the approaches to this classification is to have prodrugs, no, or permeation enhancers. And lastly, we have BCS4. Meron siyang low solubility and low permeability. So relatively, kung ano yung challenges sa class 2 and class 3 combined, no? Yeah. So these are the examples of different, siguro familiarize nyo na lang, hindi naman na kailangan sabi-sabihin. No, siguro yung mga most mga famous lang na mga drugs na pwede nyo maalala and different BCS classification. Nasa ano ba yun? Nasa hanap. So BCS class 1, exempted na yan sa bioequivalence. Class 4 is required kasi it has low solubility and low permeability. Class 2 and class 3, they are waivable and we do biowaivers. So it is means that the in vivo bioavailability and or bioequivalent studies may be waived, no, based on different maraming requirements, no. And oral solution requires no bioavailability since it is already in the liquid form. In terms of in vitro equivalence testing, so we do the solution testing that includes comparison of the dissolution profiles of the generic and comparator product in 3 media, no, in different so pH 1.2, 4.5, and 6.8. So this parang simulates the gastric and intestinal pH of the GI system. So there are also important terms, no? Like generic substitution. It is a process of dispensing a different brand or unbranded drug product in place of the prescribed drug product. For example, nag-prescribe ako ng gamot sa cholesterol, atorvastatin. Pero kasi hindi kayang bilhin pala ng customer. So that is generic substitution. Gusto niya yung generic lang na atorvastatin yung kayang bilhin. So yun, that is generic substitution. Pharmaceutic alternatives. So you are giving drug products with the same therapeutic moiety but different salt, ester, or complex. For example, ang nareseta ng doctor is tetracycline phosphate. Pero ang available lang is tetracycline hydrochloride. So since pares naman may 250 mg ng tetracycline yon, technically, So, yun na lang ang binigay mo, yung isa na lang. Same lang. Okay? That is pharmaceutic alternative. Pag sinabi ng mga, or, eto, different dosage form and strengths within a product line by a single manufacturer. For example, Alaxan. Di ba may Alaxan FR sila? Pero same lang naman yung laman nun. Yung isa lang, fast release versus yung regular lang. Eh wala ka na ng FR. Eh ito lang po, Alaxan lang, di naman press ng po. So that is pharmaceutic alternative. So ang requirement lang, pag pharmaceutic equivalent, the drug product with the same active ingredient, dosage form, dosage strength, mode of administration, and standard of quality. Pag pharmaceutical substitution, the process of dispensing a pharmaceutic alternative of a prescribed drug product. For example, ampicillin suspension in place of ampicillin capsules. Or tetracycline hydrochloride in terms so pwede rin siya, no? So relatively basta same ang moiety. Therapeutic alternative, ito naman yung pag sinabing therapeutic alternative, same drug class, same effect pero ibang drug. For example, ibuprofen instead of aspirin. Kunyari pain, kasi dati ang aspirin ginagamit yan for pain and fever. Hindi ko alam kung naabutan nyo pa. Mga neoaspilette, mga ganyan. Dati yan yung mga gamot